Hello and welcome to the walking talking topic on tree diagrams, question number 3 with me, Mr. Barton. Right, if you thought the last question was hard, wait until you see this one. Each of 8 cards has one factor of 70 on it. The 8 numbers are all different. So here's my 8 cards. Each one has a factor of 70 on it. 2 cards are selected at random without replacement. That's going to be very important. That's, as we talked about before, going to change the independence of things. It's going to mean that fractions are going to change and all that. Calculate the probability that the difference of the 2 numbers is odd. Calculate the probability that at least one of the selected cards is even. Well, we can't do anything until we know what these flipping cards are. So, each card has one factor of 70 on it. The 8 numbers are all different. Right, let's get our factors of 70 down. So let's pair them up. We can have 1 and 70. 1 times 70 is 70. We can have 2 times 35 is 70. We can have 7 times 10 is 70. And 70 is also in the 5 times table. 5 14s are 70. Alright, there's our cards. Now, calculate the probability that the difference of the 2 cards selected is odd. Now, flipping heck, there are a few different ways of doing this. I'll tell you the way I've approached this and see whether you like it or not. I'm going to label whether each of these cards is odd or even. So 1 is an odd number, 70 is even, 2 is even, 35 is odd, 7 is odd, 10 is even, 5 is odd, 14 is even. Now, difference is all about subtraction. Let's think, what are the different ways that we can get an odd number when we subtract? Well, let's get all our combinations. Say we did an odd number and we took away an odd number. So an example of that might be something like 11 take away 7. What's that going to be? Well, 11 take away 7 is, if my maths is right, is 4. So an odd take away an odd gives us an even. What about if we do an odd take away an even? What do we get there? Well, let's try it. Let's try 11 take away 2. 11 take away 2, so I should have put 4 in there, is 9, and 9 is an odd. Okay? What about the other way around? An even take away an odd. Well, let's take something like 10 take away 1. That's going to be 9 as well. So an even take away an odd is going to be an odd. And finally, an even take away an even. So let's take something like 6 take away 4. That's going to be 2. That's going to give us an even number. So there are all our different possibilities. So that's going to be quite useful to us. Let's take a bit of this. If we are selecting 2 cards at random, it doesn't actually matter what the numbers of the cards are, as long as all that seems to matter for this is whether they are odd or even. So that's going to make our job a lot easier. So what I'm going to do, I'll do it here in fact. Let's get ourselves a little tree diagram on the go. So instead of giving all the different numbers, let's say that the first card can be odd, or it can be even, and then the second card can be odd, or it can be even, can be odd, or it can be even. Okay. Well, what's the probability that one of the first card we pick is odd? Well, how many odds have we got? 1, 2, 3, 4. 4 out of 8, so I think that's just a half. What's the probability that in fact, actually, I'm breaking one of my own golden rules there. Let's leave it as 4 out of 8. No point simplifying on a tree diagram. What about even? 1, 2, 3, 4. 4 out of 8 for even. Now, if the first card I picked was odd, let's imagine I picked a 1 out. What's the probability that my second card's going to be odd? Well, we've only got 1, 2, 3 odds remaining out of 8. So that's going to be 3 out of, 1, 2, 3 odds, but out of, we've now only got 7 cards, so it's going to be 3 out of 7. And that's why I was saying there's no point simplifying on a tree diagram, because then you can always check that your denominator has gone down by 1 if you do without replacement. What about an even? Well, again, pretend that this odd's come out, so pretend number 1's come out. How many evens are left? 1, 2, 3, 4. Out of 7 cards, so it's going to be 4 out of 7. There's still 4 evens in there. If you pick an even out first, so let's say this number 14 comes out. How many odds are there? 1, 2, 3, 4. So it's going to be 4 out of your 7. How many evens? 1, 2, 3. 3 out of your 7. Okay, so calculate the probability that the difference of the 2 numbers will be odd. Well, which ones give us a difference of odd? Well, we've seen here that odd take even gives us a difference of odd, and we've seen here that even take odd gives us a difference of odd. So let's just get these two together. We have got probability of odd followed by an even. That's going to work. So that's going to be 4/8 times by 4/7, which I think is going to give me 4 times 4 is 16, 8 times 7 is 56. We'll worry about simplifying that in a minute. And probability of even followed by an odd, well, that's going to be 4/8, and that's going to be times by 4/7. Same thing, 16 out of 56. If you combine those two things together, 16 plus 16, I think you get 32 out of 56, which I think I'm going to stick for as my answer there with that one. Oh, no. Yeah, perfect. Yeah, I thought I'd made a mistake there, but no, I'm happy with that. 32 out of 56, I reckon, is the probability there with that one. Right, so what about this one? Calculate the probability that at least one of the selected cards is even. At least one of the cards that you pick out is even. Well, that's actually not too bad, especially since we've got our tree diagram here. So which ones are we interested in there? Well, we only need at least one even. So odd, that doesn't give us it. Odd even, that does. Even odd, that does. And even that does. So we can do this a number of ways, but I'm going to use the fact that I already know what the probability of odd and even is. So I already know that the probability of odd and even is 16 out of 56. I already got that from before. I already know that the probability of even and odd is also 16 out of 56. So the only one I'm missing is even. So let's just get this one. The probability of even followed by an even, because that gives us at least one even, is going to be 4/8 times 3/7. So that's 4/8 times by 3/7, which I think is going to give me 12 out of 56. So if I join in to the gang, even, that's going to give me 12 out of 56. And if I add those together, I've got 16 and 16 is 32 from before, plus another 12, I think that's going to give me 44 out of 56. And again, I can simplify that if I want. But flipping heck, that was a tricky question, that one. And if you didn't label these as odd even, you could have the biggest tree diagram in the whole entire world. So really, really, really challenging question, that one there.